Hello. Right. Yeah. It'd be fine because I can hold it here and people can hear me, right? So. What about the other one? That's got to be better, right? Because then I can keep my hands free. Let's try and use the. Hello. Totally. Then I can keep my hands free, and then I don't look like a complete moron. Success? Sorry? Success. Yeah? How can you tell? Right. You can hear me. We are on light duty. Right. Fine. More beer.
Hello, can you hear me?
Introduce the introducer. Stand in the middle. Wait. Ready? Thanks. But one of you is. Cool. That's a terrible introduction. I'm a little worried. Cool. So, has anybody been to? Did anybody go to XConf this year? Cool. It kind of gives an impression of kind of what you can expect out of this talk. So, Lantern, an artistic IoT project with little value. So, Lara's done a reasonable job of introducing me. My name's James. I'm a UI developer, UX type person with developer background with ThoughtWorks. And this talk is about a sort of one of the little pet projects that I've been working on. Before we get to why, just to get an idea of the audience. So amongst the audience are all sort of developer background, developers. Cool, right, don't need to bother with anybody else. PMs, BAs, the sort of the crust of the project. So really, why? Oh, by the way, feel free to interject, heckle. I'm not expecting great things. Some things are almost certainly going to fail with live demos. So it should be quite good fun. So why? So I'm a UI dev. In my spare time, I like to sort of tinker with things. I've tried time and time again to try and write my own blog or build a website, and that stopped. Fine. And so this is my website, and you can see that it's full of lorem ipsum text, and it's a bit boring. And you pick up these sort of things, and you start playing. And then you sort of your interest wanes over time, and you never really finish. Also, the world is changing. It's not, we don't just live in sort of like a web world. We now have access to hardware and things like IoT, Raspberry Pi, Arduino. We can actually start building stuff, and the barrier to entry has dropped significantly in the last few years. So I've started to pick up this sort of stuff in my spare time and start tinkering. So this is one of our pet projects, or I say it's my pet project. A friend of mine in Sydney, we decided to build a quadcopter. And not just any ordinary quadcopter, because you can buy one off the shelf. But we decided we would build it from scratch, and we would write the flight controller on an Esperino, which runs JavaScript. It sounds like a great idea. But actually, the idea was to just sort of get an understanding of how these sort of things work, and just sort of, if it failed, it didn't really matter.
Look, up in the sky, it's a bird.
It's a plane!
So we've got an issue with landing, but the flight part works. So actually, it was reasonably successful, sort of, until the 30 seconds that it sort of crashed into the ground. But it was the first time we sort of started to pick up and work something with technology, but in a slightly different context. Also, whilst they're spending time in Sydney, if anybody's been in Sydney at the time of year, Sydney runs a light festival called Vivid Sydney, where they turn the harbour area of Sydney into like a massive light display. So this is not Photoshop, this is actually projected across the harbour onto the Sydney Opera House, and it's lit up spectacularly. Part of me thought, well, that's really interesting. I wonder whether or not you could build something to display in this sort of area. So I live in New Mills, out in Derbyshire, and in late September, they have a lantern festival. Brilliant. This is my first opportunity to try and build something that I could use in sort of a lighting display and actually display it. So the goal of this project was to build a set of controllable connected lights, something that I could turn lights on and off with. So what technology do I have available to me? Obviously, like the Philips Hue light bulbs. I can buy these off the shelf, I can put them into my house, and I can buy the hub, and I can control them. I promise they're quite expensive, and they're not easily scalable. Every time I have to buy a light bulb, possibly more on the hub itself. So I thought, like the quadcopter, yes, I could buy it off the shelf, but I want to see how I can build one myself and understand each component part and see how far I get. So a few years ago, at an internal event, we were given one of these. Now, this is a development board for a Wi-Fi chip with some connected lights. And that was going to be my first starting point. That is an ESP8266 Wi-Fi chip. It is the sort of the maker choice for Wi-Fi, relatively low powered, connects to Wi-Fi, has a multitude of sort of Wi-Fi libraries available to it, also connect to Wi-Fi hub or run its own little Wi-Fi hotspot. So there's lots of room for experimentation and tinkering with. It also only has 2 output ports, and you can program it and control it similar to an Arduino. So this is what the chip actually looks like on its own. They are very, very small, and their saving grace is the fact they are dirt cheap. So you can pick one of these up for 2 or 3 quid off eBay, and they'll ship them from China eventually. So naturally, when you get home, you think that's a great idea. I bought 5 of them, and they went into a cupboard, and I ignored them and didn't do anything with them until I came up with this idea of, okay, I'm going to build lanterns, connected, controllable devices. So other part of that board was a collection of addressable LEDs. So any of you are aware of sort of Adafruit and NeoPixel. So this is an Adafruit NeoPixel shield, and each one of these lights, of which there are 40 written across the middle. You can control each one, and you can change the color of each one and the brightness of each one. So each one is individually addressable. And yes, Adafruit stuff can be quite expensive, but you can buy the chip itself, each LED. So I thought, oh, well, I will use LEDs. There's a library to drive the LEDs, so that gives me my input and the control and the sort of the output. So what protocols am I going to use to talk to each lights? So a first attempt, basically using REST. So it sets up its own little Wi-Fi stack. connects to Wi-Fi, and you can send it post requests or get requests. From this, it's quite difficult to sort of deal with that sort of level of input, and they would crash quite regularly because they're low powered and relatively cheap. They're rubbish. They would just crash left, right, and center. So it's not really scalable. I can't tell whether or not something's active. Another choice is CoAP, which is Constrained Application Protocol. It's sort of like a mini version of REST designed for these sort of devices. And at this point, I'm going to admit that I didn't choose CoAP, so I can't really talk at any great length about it. But it's an interesting one to experiment with. What I actually went with was MQTT, which is the messaging protocol worked on publish and subscribe on topic level. So this was going to be my transport mechanism from something to a collection of lights. So tech stack, this is how the app actually works. So at the top, we've got a React and web front end, your usual testing. But actually, you can send post requests down to a server running Express.js because it's quick and easy. A Mosquito is going to be my MQTT broker. It's going to listen for, or be responsible for sending the instructions out to each of the lights. Also, the light is going to be responsible for sending updates back up the stack using a different topic, which I can then surface back up to web front end using just so I can keep things up to date. Because they're unreliable and likely to crash, you kind of want to get an up-to-date status of where they are. So WebSockets, nice way to get back up. So how are we talking? So MQTT works off topics, so you can subscribe or publish to a particular MQTT topic. So I'm going to use a topic called Connect, and I'm going to send information, sort of diagnostic information, every few seconds from each of the lights, which will basically give an update. MQTT gives a sort of a last will and testament that when it subscribes with the broker, says, when you stop listening to me, or when I disappear, then send the final message. Quite useful to know when the light is gone, but actually what you want to know is other information about the light, sort of how much memory it has, or status of the light. So in a light bulb, whether or not the light is on, or the light is off, whether or not it actually received the instructions you sent. So this is the topic, and this is the information that it's sending. So each light has its own address, similar to sort of like a MAC address. It's just a unique number that each one is individually identifiable. Second piece of information is the amount of memory and bytes that it has available to it. Particularly useful when it runs out of memory, it crashes and restarts. So you kind of want to know how much memory it has left. And then really simply, its status. Is the light on or is the light off? So 1, 0. So to send information back to the light, because each light has its own unique address, you can subscribe to a topic of its ID. So it will only listen to topics, to instructions that are sent directly to it. All of these topics, but each light will only ever describe to 2. One is its own ID. The other is sort of like a broadcast topic, so kind of like the reverse of Connect. It's sending information out. This is going to send information back in, so I can send the same instructions to all of the lights. And on the right-hand side, we have sort of a really basic instruction. So we have color, which is what I want you to do, and a hex value, which we're all familiar with on the web. So this would send the color red to the light, and the light would turn red. So the hardware that's running behind on each of these lights, beyond, I've only got one of these little boards. So this is what it actually looks like. Now, this isn't, I'm no electronics engineer, and there are people that are going to correct me on this. But basically, all the electronics are doing is a voltage regulation, just to provide 3.3 volts, a steady 3.3 volts, the chip, and the remainder that are sent to power the light array. So it's all really simple. There is just a voltage regulator, a couple of capacitors, nothing particularly complex, but it's cheap. What I'm going for here. I want to build as many of these for as little money as possible. So the lighting array. So NeoPixels that I mentioned earlier, or something. These individual chips, they come in a multitude of different arrays. So they come in sort of like long strips. So similar to the lighting strips you see running up and down the office. So each one of those is addressable, and they come in a long line. They come in rings, they come in sort of squares. But actually, I'm not quite sure what the lighting effect from a sort of an artistic level of what the light is actually going to look like. And if I buy each of them individually, so I can buy them individual, about 100 for about a tenner, fiddly, and soldering them is an absolute nightmare, but it's cheap, and I can change the configuration. I can put them in a long line, I can make them in a ring, and also see what it looks like, because at the moment I'm not quite sure what it's actually going to look like. So this is what happens when I badly solder 5 of them in a row. So this is my terrible photo is beautifully cropped, so you can only see the top side, the bit that I haven't soldered. But there are 5 of them, and that took an awful lot of time to solder. But the idea is that I can put them in a long line, or I can group them round in a cluster. So how am I going to power them? So there are lots of different options available to me. I can have a LiPo battery, which packs a significant punch. They can be quite explosive, but they're also quite expensive. And still going back to the cost, I could buy 5 of them, but the electronics to charge them and discharge them, handle them safely, is way beyond what I'm going to do for the project. A little 9-volt battery, smaller, easy to transport, can be quite expensive, and it's 9 volts. I'm only dealing with sort of somewhere between 3.3 and 5. I'm going to waste a lot of energy. Or I could go with sort of AA's, either rechargeable or whatever non-rechargeable batteries are. So they're slightly different voltages, so non-rechargeable, whatever the 1.5 volts. The rechargeable ones are 1.2. So actually what I went with, good old IKEA, is rechargeable batteries. Because they're 1.2 volts, I need 4 of them, which will give me 4.8 volts, which is enough to power the lights, and I can step that down for the light. And because they're high capacity, good old IKEA, they're good for running torches, so they're good, perfect for my application. They do take up quite a bit of space, but it means that they're rechargeable, so I don't have to bin them every so often. Admittedly, I could use 3 if I went to the other type, but once they run out, they're binned and expensive, and it's pretty wasteful. So rechargeable, I get the charger, and so how are we going to talk to each other? Originally, I had a Raspberry Pi that was going to run the sort of the broker Mosquito, and run the Wi-Fi network. But it turns out that configuring a Wi-Fi network on a Raspberry Pi running an ad hoc network isn't and the range is rubbish. And actually, a colleague of mine said, "Hey, why didn't you buy one of these cheap routers from China?" So this is an OpenWRT router. It is tiny. So it is this here. And so that can act as my sort of Wi-Fi hub that all of the lights connect to. It can also, because I can install software on the router itself, I can install Mosquito on the server. So the hub, when the lights turn on, I'm just going to look for the same SSID that it's expecting and connect, and it knows where the host is. Connect to that and start subscribing to topics. Cool. So software. So programming the chips. The chips themselves have firmware on them which allow you to write Lua. Has anybody written anything in Lua before? Oh, that's good fun. The only language I can think of that doesn't have 0 as a first element in an array, it's 1. It took a while to work that one out, I can tell you. But yeah, so basically, this is an application, Java application called Explorer. I'm not quite sure how you pronounce it. But basically, you connect to the light on my dev board, and you connect to it through a serial connection, and you basically just write each file to the chip. When the chip boots up for the first time, it will look for an init.lua and then run that file. If it crashes at any point, it just restarts. So if you've got an init.lua file that crashes, you get stuck in this infinite loop of horrendous. And they're really difficult to get out of. You have to flash the firmware and cry. You can also build your own custom firmware. So this is the Node MCU custom build. And at the bottom, you can see all of the different sort of Wi-Fi, different modules that you can install on Lua libraries that connect to different things, so that turn lights on and off, all sorts of different libraries, and you can configure your build to only use the libraries that you actually want to use. It saves you a significant amount of space, which means you crash less often. And actually, for this application, I only really need the stuff that controls the lights, connects to Wi-Fi, some timing stuff, and the MQTT library. So I can strip out all of that crap that I don't need and keep it relatively lightweight. also to test the MQTT stuff. There's another Java application called MQTT5. There's loads of these different things. And you can subscribe to different topics and pretend to be a light. And you can see the messages traveling backwards and forwards. So this is me subscribing to the Connect channel. And you can see that my fake light 54321 with some dummy memory has responded. So I can use this to not only subscribe just to check that the message is going backwards and forwards, but actually you can send instructions to the lights without any other. So the result, so this is what it originally looked like. So I have a collection of lights that appear and disappear in sort of like a web dashboard, and the light on the right-hand side, so I can toggle this switch on and off, and the light turns on. To achieve this effect, so I can put them all, and I can send each one an instruction or a color to turn a color, and I've achieved my goal of programmable lights. But what if I make it more interesting? How do I achieve animation? So if you break up what animation is, so I could send lots of different instructions at a lot of time, but the more lights I've got, the more instructions I need to send. So I need a way of sending an instruction to a light that it will then just draw. So this is what my animation would look like. So I've simplified it because otherwise it gets insane quite quickly. I have five frames in a sequence animation, and I have 2 bulbs, 1 and 2. So I want to alternate those 2 bulbs on and off in 5 frames. So I take my original approach of sending colors. I give each one a hex value. So off is obviously black. And I put them all in one long line, and I get a ridiculously long instruction string. But now the color's not quite going to work anymore. I need a different way of instructing these lights. So I introduce animation. So this is, I'll point out at this point, this is all custom built. So there are probably an infinite number of ways of doing this better, but this is the approach that I took. So animation now needs more information to it. So I need to know whether or not the light is going to loop, which is the last one in that list, the number of bulbs that I'm going to animate. So that long animation string, where do I break it up into each frame? So 5 is the number of bulbs that I'm going to draw. They've all got 5 anyway, so it's kind of, I thought I would extend it so I could add more lights at a later date. 1 is the number of frames per second you want to draw. How often do you want it to update? So I've also got more instructions to stop and clear the light. It's not just on and off anymore. Previously, I could have turned the light off by sending it a black instruction. Now I can send it clear and stop. So one will pause, the other one will turn the light off. So now I get this really long animation instruction. And it works, but because the lights are quite flaky and there's a limit to the amount of information I can send it in one go, I wonder if there's a way of shortening it down. How can I encode this in such a way that that instruction string is a lot shorter? So when I take down each color, what I'm sending, when I'm sending the color red, FF0000, is the numbers 255, 0, and 0. And you can store the number 255 in a byte of data. But actually, I'm using 6 bytes of data here to transfer them in ASCII. So I wonder if I could use the ASCII table to encode the data. Now, this is by no means a good idea, but it was an interesting idea, one I thought I would follow. So I wonder whether or not I can encode the data of the lights for red, green, and blue into the ASCII table and sort of print that out instead. And obviously, there are some ASCII characters that you can't print out. Things like escape, backspace, return don't work in a string. Well, they do work in a string, but it's not something that's easy to send. And also, you can't use backspace because backspace would delete it. That leaves me with this remainder of characters left that I can use to encode red, green, and blue and shorten that string down. This is the one that I didn't have a chance to put in, so you're going to have to excuse my crappy handwriting. But this is kind of the rough flow of how it works. So you take red, green, and blue, convert it to decimal values, divide it by 2, gives you 7. And then you shift those numbers to try and fit within that range of ASCII characters, and then convert that to a char code. So basically, the light is just going to do the reverse of this. It's going to take each light, reverse. So actually, the number I get back for white isn't 255, but actually, they're so bright anyway, it doesn't really matter. So I'm prepared to forgive the fact that I don't have 16 million colors available to me, because the lights are so bright that basically 13 million are white anyway. So this is what my animation string now looks like. It was a bad example, and I realized this when I put it up, is that 0 is essentially a space. And spaces don't really print that well. So the bits between the tildes are white, or black actually. So what's the UI look like? So now I've got to build a sort of a simple programming interface. So this is what React and Material UI gets you out of the box surprisingly quickly, with a few installs and pushing stuff, wiring your events together. So I have a UI that shows all of the lights appearing, and then an animation screen that allows me to set each light, or each bulb in each light at a particular point in time. And I can build out quite complicated animations surprisingly easily. So this is where it goes downhill quickly. You want to turn the lights off, and I'll turn the lights on. So diagnostically, what the light is going to do is write to the light string that tells me a different color depending on what it's doing. So red, it's turned on; yellow, it's connected; green means it's connected to the Wi-Fi, and it now should start blinking. It means it's connected, and it worked. When I go this way, I have a light. So I only have one at the moment. So I turn the next one on, and they should appear. This works in rehearsal. They should appear in sequence. There we go, we've got yellow. Green, and then as the green light goes off, it should appear here. There we go, next one, and finally, cool. So I now have 5 lights all running this animation. So we have white and black. So I can now stop one of them, turn off, turn on. Not particularly interesting. But now I've got a full animation builder. This looks slightly different. It's a slightly refined version, but the things that I can change, the colors of each bulb at a particular point in time. I can add frames. I can choose whether or not I want the animation to loop. I can choose how quick I want it. Is anybody epileptic before I go any further? Didn't mean to ask at the start. But if I wanted it to go, let's make it blink red really quickly. Not particularly interesting, but you can actually build quite complicated animations reasonably quickly. So if I wanted to do something, put some blue in there. And then I'm going to put a couple of spaces in. So the astute among you might work out what this is going to do. Slow down a bit, it's not quite ridiculous. So you get some kind of like NYPD crazy effect. And actually, because you want to program all of them at the same time, if you want them to select red, you can send the same instruction to all of them at the same time. And they should all start roughly at the same time. So this gets, at this point, it got quite fun just to play with it. I mean, not getting beyond sort of like how it actually works, but actually you can build sort of quite complicated things quite quickly. So that works. So they don't synchronize. It's a quirk. So you can program each of them individually, but you can stop and start them all at the same time. So there is, at the moment, I did talk about the color in channel, which basically sends the same instruction to all of them. But actually, because there are only 5 of them, you can send each instruction to each light, and they start roughly the same time. Every now and again, you might see one that one of the messages gets sort of delayed along the way, and one of them will start slightly later. But for the most part, they're kind of in sync. And I won't do it now because you'll get bored of me setting it up. But you can get them to all animate the same thing, but a different frame at a different time. So you can get them. So it's not just animations within each individual light, it's animation across the entire rig. So what went wrong? So this is the ThoughtWorks accident book. And the tech principle of the North fanning the soldering iron whilst I tried to put one of the lights back together when I first gave this talk. So yeah, the soldering aspect and electronic engineering is not my strong point. Soldering certainly isn't, but actually it's an interesting thing to pick up. So programming the lights is really painful. Like I haven't come up with a neat way of doing sort of over-the-air updates, because that would be your ideal, right? Is to be able to update each light whenever it receives a different instruction, or tell it how to interpret each instruction. And every time I decided to change my approach would then mean programming one light. And because you have to program one light, you have to program 5 or 6 lights. Each change would then mean you then have to spend the time of writing each individual file to each individual light, of which there are 6. And each one is written line by line. So the actual uploading to each light takes about 5 minutes. So to change each instruction, so particularly the getting the animation bit, took an awful long time. Also, the color doesn't quite map. So this is a bright pink color, but actually because you're mixing red, green, and blue, all at the same intensity, the color actually comes out a lot brighter. So in a web UI, pink looks quite pink. On the lights, they will just look bright white. So there needs to be some sort of interpolation to work out what colors map to what color. But actually the effect is quite good and better than I was expecting to be. So this is no, last gave this talk without the sort of lampshades. It's actually surprisingly effective. I wasn't expecting it to be quite so effective. I'm almost surprised at how well this works. So what's next? I've got 5 lights. Theoretically, I could have more. The problem is the cost now is increasing, and I'm still not entirely bought into the fact that this is the correct way to solve the problem. But if you want to invest in my Kickstarter, it would be really interesting just to see how many you can add. Also, when we go back to what's actually controlling this, and what makes it slightly different to sort of like the Philips Hue or whatever the IKEA controllable. The bit at the top is the interesting bit, sort of from sort of HTTP down, because I've got an endpoint, a RESTful endpoint, and if I told you what the endpoint was and what's opposed to it, you could control each of these lights. You don't care about anything further down, but you can now think of other things that might interact at the top. I'm going to turn the lights off again. I haven't tried this, so I'm not quite sure if it's going to work. Alexa, turn on the light. Oh, thank God that worked. Alexa, turn off the lights. So now I can build my own sort of front ends to this. And I can change how it works. Anybody on Twitter? I know there's certainly one person. Right. So the hashtag Manchester Geek Nights. This is going to get interesting because I'm not sure if this is going to work. So just a suggested tweet. Manchester Geek Nights, what a badass, which is a valid color. You don't have to put out Mudwell and Beers, it doesn't matter. But basically, if you tweet with Manchester Geek Nights and a valid 6 code, it will turn one of the lights that color. Almost have a competition as well. So solid colors tend to work quite well. So if we were to hashtag FF0000 would be red. And it will choose a random animation to draw. So sometimes it'll blink. Oh, we've got white. That was exciting. Oh, we've got blue. So I can think of different ways I can interact with it. It doesn't necessarily have to be sort of my sort of Alexa. Doesn't have to be that, but I can think of anything that can, and I can connect up the world in a different way. So how does this work? So I talked about this before. Node-RED is the magic behind that's making this work. Node-RED, IBM product. Anybody use it? Good for sort of prototyping IoT type stuff. Does anybody remember Yahoo Pipes? Did anybody use Yahoo? Yeah, so there's finally people who understand Yahoo Pipes. Everybody sort of looks blank face. So Yahoo Pipes, for those that aren't interested, it was a way of sort of a different way of looking at the web. You could wire different things together. So you could take a JSON and wire it into sort of Flickr, and you could create different ways of getting the web to talk to each other. The Node-RED is kind of like the modern day equivalent of it. You can choose a multitude of different inputs from sort of like injected sort of demos of WebSockets, post requests, and then you can pass that information through lots of different functions or different manipulations, and then spit it out the other end. So you can take things, you can put like a RESTful front end over an Arduino, for example. You can write to a serial port that would change a particular value to drive the servo, or you could feed information back the other way. A really good way of prototyping things really quickly and really inexpensively. So this is kind of like my mantra now, is trying to, let's make tech fun again. Let's stop building these sort of like crud web front end, like big enterprise architecture, and actually pick up some of this sort of Arduino, Raspberry Pi, other cool stuff, and make things fun again. Alexa, play disco. Come on, Alexa, Spotify. So I'm only going to enjoy this. Alexa, volume 10. Alexa, turn on the disco. So actually, that's a good example of where one of the lights hasn't quite caught up. So it's actually running slightly ahead of the others. But it actually can make this, you can make this more fun. Actually, that works quite well. I'm surprised I hadn't actually seen it work. But I can choose, I can show this afterwards. You can choose any number. Alexa, stop. Alexa, stop. Thank you. You could choose any number of different sort of, basically Node-RED in this case is pretending to be a Wemo. So this flow is more complicated, but there are two, the bits on the left-hand side are basically pretending to be a Wemo device that would receive two instructions. So I have a node name of the disco. Its friendly name is what Alexa will read out. And then a unique identifier for each of the lights, and then what you kind of want it to do when a light is turned on or off. And then you can pass that through my insanely complicated setup, which works out whether or not you're turning the light on and off. If the light goes off, then you basically just send it an off instruction. If you're turning the lights on, then you want to get all of the lights from my RESTful endpoint, and then iterate through each of them, and then send the instruction, the relevant instruction to each of them, whether or not we want to turn the lights on, or whether or not you want to turn the disco on, and then post that to the API. So you can actually start to build different kind of interactions and different interfaces quite simply. So this took a couple of hours because the looping bit was really fiddly. Prototype that sort of thing. You can think how long it would take to build that in the wild. You just sort of, you can build stupid shit really quickly. Like this. So what's the next stupid shit? This is the question that I got asked when the last time I did it was, okay, you built the lights now, what's the next stupid thing? This is a 1930s rotary dial phone. And this is it plugged into an Arduino with a GSM shield with an aim to becoming the first proper hipster mobile phone in Manchester. So by Christmas, I'm going to stand in Manchester and have a proper rotary dial phone. So look out for that. So that was kind of where I got to the end, a crappy ending. But thanks a lot. If anybody wants to have a go or think with it or ask any stupid questions, fire away. Yes. So everything is running off a laptop, rightly or wrongly. for the moment, but it's working across the network. Yes. So it basically, it basically just steps up the service the same way that Wemo itself does. When Alexa is scanning for it, it scans in the same way. The node red is basically just a wrapper for a node library that does the same thing. After all of this effort and time, I was actually on holiday for the Light Festival. So I never actually got a chance to do it. So hence the reason for sort of doing the talk, just to see whether. So that's the next. There is something. So I did have a look at a few sort of Spotify examples to see whether or not you could get it to synchronize the music. That would be awesome. Like the things at the moment, it's you see what each light is doing. This is sort of like that diagnostic information that you sent back. So each light is basically just going to ping back every 5 seconds that piece of information. So you should see this number updating the last time the light sent a last status update. And also, this is the amount of memory that it's got left. Because it's not doing that much. All it does is, when you send it that instruction, decode the instruction and build a sort of an in-memory buffer of what it should do. So it's actually a really small amount of information. This is only 8 frames for 5 different colors. So it's actually not that much. The difficulty is getting the instruction to the light quick enough for it not to crash. So actually, the next bit is to not send it one instruction, but send it to chunk that instruction up. So you can actually program it whilst it's doing something. So if you send it another instruction, you'll see them all stop for a second, think about it, and then start again. And actually, it'd be really interesting just to sort of send it to program them remotely, and then tell it to, you send it an instruction to render between 2 points of memory. Or synchronizing them would be really neat. Or lots of them. And I kind of want to go with the lots of them, but it's too expensive. Yes. So I always wanted to put one in a window in a building and play Tetris across the building. But I don't think my finances stretch that far. Yes. So, to break up your question, is that how Coldplay do it? I don't. They could talk to each other, because they're all talking through the same broker. So if you get them to subscribe to different topics as well, so they only subscribe to the topic server is sending information. You could get them to subscribe to other ones. So it would be quite interesting to see how they interact. I haven't really sort of dove into it that far. I'm not sure whether or not Wi-Fi is the way to go when you have lots of them. But there are lots of other sort of protocols like Zigbee or some other sort of Bluetooth Wi-Fi. Yeah, it'd be interesting to see how you do it at scale. I think there's probably some radio things perhaps. Because that's another cheaper way of doing it, perhaps, is to broadcast the instruction, and each one is sort of listening for it. Because they're all synchronized at the same time, right? But yeah, all of these stuff, you could think of many stupid little applications. There's basically just 5 lights and different colors too. But sort of you start to think about how you can start playing with them. So build lights that play disco, or meeting rooms that turn red if people overrun. My 2 favorite ideas at the moment. Yes, yes, you can. So, no, I'm muted there. Alexa, turn off the lights. Alexa, turn off the lights. So, is it that one? No, because we're not in PowerPoint. There we go. Alexa, turn on the lights. that is a fairly slow animation, but you're changing, but the sort of the darker colors are going to be less bright. So intensity for white is quite easy. They're all sort of from 0 to F. You set all of them to the same, and then get them to sort of raise up. I'm not sure whether or not you can keep the same color, but less bright. It gets quite fiddly. I don't know enough on sort of color and color mixing. You can change each bulb within a light. You can change that sort of setup. So each one is slightly lighter. Lots of different ways of doing it. Spend some time playing with the little sort of animation. We'll just see sort of what the effects you can get. Because at the moment they are clustered around in a ball. If you extend them up to the middle of the light, you get a slightly different effect. So, I'm not sure. You got a question I can answer? Because the message received on the other end is text. Yeah, it's just a string. So I thought I'd try and. I think because each color, certain hex colors, well, 6-character hex would give you 16 million colors, but it can't draw 16 million colors. They're all just too bright. So actually, solid block colors are the ones that work better. So sort of red, yellow, blue, green. So actually, sending the instruction, each light knows a particular color, and then assigning a character to a color is probably an easy way of doing it, rather than sending lots of different color strings that are bent essentially just white anyway. But there are probably lots of different ways of sort of sending the same instruction to them. It's basically just trying to overcome that. How do I send an instruction to the light as quickly as possible so I can move on to the next? Yes. Yeah, so there's another way of achieving the same thing, just slightly more complex. So I was going at color, but you could do it to animation. Preload lots of different animations. Or have animations, which is essentially just a function that just says at this point in time, do this. So either shifting your buffer to get some kind of like scrolling effect or sort of changing things on and off. You don't really want to send it an instruction to turn the light off. When you send it one instruction, you can do interesting things like sending it a delta or all these multitude of different ways of achieving something. But this is relatively low tech and quite simple. Cool. Awesome. Well, thanks a lot. It's been good fun. Why?